G'day everybody, where's Wally here? Oh, Captain Incredulous is at it again. You know, I thought Adam had enough yesterday. He copped a real pasting when he decided that the Crew 2 capsule had to be travelling at escape velocity to reach orbit, which of course we all know it doesn't. But poor Adam, he doubled down a couple of times on that point. But Adam, you do know that the Space Shuttle and the ISS are travelling at 17,000 miles per hour, roughly. So why do you think that the Crew capsule has to reach escape velocity to then slow down to dock with the ISS? We're not sure how that works, mate. Anyway, let's have a look at his DERP today.
And they were real cooperative, giving me great GCAs. Here you can see him saluting the flag up.
Good old Jerry saluting the flag there. But I've got to pose the question here, my dear. Is Jerry really upside down attached to a mechanical robotic arm which is attached to a space shuttle which is doing 17,000 miles an hour upside down around a spinning ball?
Well, Adam, yes, Jerry is. You know what? I think you're going to have to treat the globe earthers a little bit differently than your little sheep, because we do things like, you know, check the original sources. So what Adam didn't want you to see was what was shown on the original video just prior to this. This shows Jerry outside putting this thing together.
This is a good view of us performing the access build. This is Woody with his back to us in the front foot restraint, and I'm facing the cabin in the back. We just completed one bay of the access truss, and we are starting to take components out to start another bay.
Well, how about that, Adam? That really just shoots your whole pantomime theory right in the foot, doesn't it, Adam? Because the information is right there on video. Jerry put it together outside. They were working for hours doing it. Thanks, Adam.
I don't entirely know exactly what's going on. Now, in the second clip, we get to look out of the window of the shuttle and look down upon the Earth. And what we get to see, supposedly, is amazing. From an altitude of 230 miles up, with a length of 122 feet, we get to see, supposedly, the shadow of the space shuttle cast upon the Earth.
So Adam thinks that this is the shadow of the space shuttle on the ground. Adam, who says that? This would have to be a flat earther you're listening to, because no one is going to think that the space shuttle is going to cause a shadow from that distance, because when you look at the angular size of the space shuttle from the ground against the sun, oh, how about that? In no way does it cover the entire disk, which it would need to do to cast a shadow. So Adam, I think you're just a little bit off track yet again. Anyway, let's all have a laugh as Adam looks out the window, sees a speck of dust on the window and thinks that it's the shadow of the shuttle on the ground as it passes over the Arabian Peninsula. Good one, Adam. Well done. Keep up the comedy stuff, mate. We need a good laugh.
I don't entirely know exactly what's going on.
So Adam, I hope you follow this up with part 2 like you did last time, because that was the one where I busted you for cherry picking over Chicago. You really got the wrong speed that day, didn't you? Because you didn't make the allowance for the shuttle doing the fly around. I wonder if you learnt your lesson. Let's wait and see if Adam is game to pop up the second video again. Let's have a look at how that turned out for you last time. This was so bad for you, Adam.
So here's image 1, the start of the journey, obviously highlighting the Soyuz as our line of sight target. Image 2 at the end of the journey, 11 seconds later, again highlighting the Soyuz as our target. Now, between the 2 points of reference is 120 miles. I know it says 121, but it's 120 miles between the 2 points of reference.
But at least I have taught him how to go about measuring the speed of the ISS. Let's see how well Adam did at this.
So let's see how fast these guys were actually travelling. And we calculate. And we get a speed of 39,272 miles.
Oh, 3 times faster. Well, Adam, that's not right. Okay, so when a person of science gets a result that is clearly an outlier, they usually question themselves. Did I do this right? Did I stuff up, or is this a fantastic scientific discovery? Answer is you usually stuffed up. But what did Adam do?
At how fast they're travelling, and it would seem NASA need to slow their bullshit down a bit.
He claims that NASA is wrong. These results fit his fantasy, so this is what Adam does. Well, let's independently recheck Adam's work and see where he muffed up, because we know he already has, but let's just see where it is. So I grabbed 2 frames exactly 10 seconds apart, none of this rough guessing stuff like Adam did. Adam, he used a sight line to go past the ISS. I will just use the frame as a reference, which is much the same as the ISS is in pretty much the same position in each frame. So I see a bendy river shift by 580 pixels, and on Google Earth, these 2 water bodies over here, they are 116.6 kilometers apart, and on the image they are 333 pixels apart. So a simple ratio shows that the ground has moved by 203 kilometers in just 10 seconds, giving us a speed of 20.3 kilometers per second. Ah, well, that's 3 times too fast. Oh. Well, Adam, seems you did your part right. So, what has happened? Because you guys, like me, know that Adam is wrong, right? Well, of course he is. Captain Cherrypick got so excited that he missed the fact that the shuttle is doing a fly-around.
Our undocking occurred at night over the west coast of the United States. We backed out to around 400 feet and then began a lap around the space station that was just nothing short of spectacular for the views that we saw. We're used to seeing this.
So Adam mentions the 2 clues. He says the shuttle is 400 feet from the ISS. He also noted the change in angle of the solar arrays.
And it turns out when I did an overlay, there's no difference whatsoever. The solar panels move slightly, as we're going to see in a minute. This is both images overlaid on top of each other without moving or doing any alterations. You can see there's some slight change in the solar panels itself.
So 360 degrees in a 90-minute orbit, that's 4 degrees in 1 minute, and for 10 seconds that's about 0.7 of a degree. Wow, Adam, these panels are moving a lot further than that. Just how far? Let's have a look. Well, we see that those panels are 112 feet long by 39 feet wide, and they move by what appears to be 9.75 feet, which, when you do the maths, works out around 5 degrees. Well, clearly the shuttle is moving, so a sight line past the ISS is changing, as Adam noted, but did he understand the error that was being introduced? Or maybe Adam did understand, and this is why he belabours the point that this is a perfect sight line. We wonder, Adam.
Because if there isn't, like there isn't in this instance, I'm going to use it as a line of sight to gauge the speed. And it turns out when I did an overlay, there's no difference whatsoever. But the actual body of the space station is exactly the same position, and so is the Soyuz rocket, which is docked at the bottom. And that is what we're going to use as our line of sight.
A 5-degree change at 400 feet is how far at 410 kilometres? Well, 410 kilometres is 1,345 feet. Now, by 5 degrees, let's say that's non-zero. So, clearly, Adam, you cannot use this piece of video except to make a propaganda piece, which seems to be exactly what you just did. So, why call you Captain Cherrypick when, at this stage, you're just Captain Erroneous? Well, the very next 8 seconds of video from the video that you used as your source shows another passage of the ISS over a coastline on the east coast.
Here we are crossing by Lake Michigan and Chicago, straight down below the station as we were looking on it. And then you'll see here coming up on the Atlantic coast with Cape Hatteras, the furthest point off to the left. As we complete the fly around there, we see the station from the backside. And looking at the horizon, it just was one of those things that we'll all treasure for the rest of our lives.
Now, this was Captain Hatteras, 1,200 kilometres from Chicago. So why did Adam ignore this piece of video? It was taken only a few minutes later, as the shadow on the ISS panels show. It would have been brilliant confirmation of Adam's contention that NASA stuffed up. Okay, well, here, let's do the same thing. Now, this is a bit of a rough scale that I chose. It's not in line with the direction of travel as I prefer, but it's the best I could do with this image. And when we pixel count and multiply and divide, we end up with 43.8 kilometers of image shift for just 8 seconds, and that's a ground speed of 5.4 kilometers per second. Now that's much more like it. So Adam, did you do this one too? And then did you cherry pick the one that you wanted? Does that mean that you're just a propagandist? Or did you not bother to do the second test? That makes you lazy. Either way, not very scientific, Adam.
I cannot believe, Wally.
Sorry about that, old bud. I guess you got ping-ponged again, didn't you, mate? Namibia. You ever going to do something about Namibia, Adam? We're still waiting for the bad day.
So please, if you're able to identify this bit of land that takes up this massive bit of the supposed spinning globe Earth, please can you let me know in the comments section, because I cannot find that landmass, as I've stated previously in the other video.
Well, if you like what I've done here to poor Adam, give me a click, like and a subscribe, and we'll find some other poor sap to deal with.